Enoch Winslow pressed his palm against the interior wall of his cabin on a January morning when the temperature outside had dropped to 20 degrees below zero and the logs felt warm to the touch. 200 yards away, Absalom Pritchard did the same in his identical cabin, burning the same amount of wood, and snatched his hand back from timber so cold it burned his skin. Before we begin, drop a comment letting us know where you're watching from, and if frontier survival stories like this one speak to you, hit that subscribe button, because tomorrow's tale might just change how you think about the impossible. The winter of 1839 came early to the Montana Territory. By late October, trappers along the tributaries of the Yellowstone River were already seeing ice form on beaver ponds during morning hours. By early November, the first serious snow had fallen. Men who had spent multiple seasons in the mountains recognized the pattern. It would be a hard winter, the kind that killed careless men and unlucky ones in equal measure. Enoch Winslow had survived 6 winters in the territory. He was 32 years old, originally from Vermont, and had come west in 1833 following the collapse of his father's lumber business. Trapping offered freedom and the possibility of profit, though the latter had become increasingly uncertain as beaver populations declined and eastern markets shifted. Still, a man could make a living if he was careful, competent, and willing to endure conditions that would break most people. Enoch had partnered that season with Nathaniel Crosby, a man 8 years his senior, who had been trapping the Rockies since 1827. Nathaniel knew the mountains better than most, understood beaver behavior, and could read weather signs with reliable accuracy. They had established a camp in a protected valley about 40 miles southwest of what would later become the town of Livingston. The location provided access to several productive creeks and enough timber for construction and firewood. Their cabin was typical of the era. 2 men working steadily could build it in 5 days. The structure measured roughly 14 feet by 16 feet, with walls constructed from pine logs, notched at the corners and stacked to a height of 7 feet. They had chinked the gaps between logs with a mixture of moss and mud. The roof consisted of poles laid across the walls and covered with bark and a layer of sod. A single door faced south. One small window covered with oiled paper provided minimal light. The floor was packed earth. Inside, they had built a simple stone fireplace in the northeast corner. The fireplace was crude but functional, constructed from river rocks mortared with mud and clay. It drew adequately and provided heat, though like all frontier fireplaces, it was inefficient. Most of the heat went straight up the chimney. The immediate area around the fire stayed warm. The rest of the cabin remained cold unless the fire was built large enough to be wasteful. They had 2 sleeping platforms built against opposite walls, raised 2 feet off the ground and covered with pine boughs and blankets. A rough table made from split logs occupied the center of the room. Shelves mounted to the walls held their supplies: powder, lead, salt, coffee, dried meat, traps, and the various tools required for their trade. 2 chairs, which they had carried in pieces from Fort Laramie and assembled on site, sat near the fireplace. It was adequate shelter by mountain standards, neither better nor worse than what most trappers built. On the morning of November 18, 1839, Enoch woke to find the cabin colder than usual. The fire had died completely during the night, which happened occasionally when neither man woke to add wood. He sat up on his sleeping platform and looked across the room toward Nathaniel's bunk. His partner had not moved. Enoch called his name. No response. He stood and crossed the frozen earth floor in his stockinged feet. Nathaniel Crosby was dead. The cold had killed him. At some point during the night, probably in the early morning hours when temperatures dropped to their lowest point, Nathaniel's body had simply stopped generating enough heat to sustain life. He had been 43 years old, healthy by frontier standards, experienced in winter survival. None of that mattered. The fire had gone out. The temperature inside the cabin had dropped below what a sleeping man could survive. Nathaniel had died without waking. Enoch stood looking at his partner's body for several minutes. There was no obvious cause of death beyond the cold itself, no signs of struggle or distress. Nathaniel had simply failed to wake up. The realization that settled over Enoch in those minutes was profound and would change the trajectory of his life. A man could do everything right, follow all the rules of wilderness survival, build adequate shelter, maintain supplies, exercise reasonable caution, and still die because a fire went out at night. He built up the fire and warmed the cabin before preparing Nathaniel's body. There was no minister within 100 miles, no formal funeral possible. Enoch wrapped his partner in blankets and carried him outside. The ground was frozen too hard to dig, so he selected a spot on the hillside above the camp and built a cairn of stones over the body. It took most of the day. He marked the location with a wooden cross made from split pine and carved Nathaniel's name and the year into the wood using his knife. That night, Enoch sat alone in the cabin and thought about what had happened. The fire had gone out before. They had both woken on cold mornings to dead coals and rebuilt the blaze. But this time, on this particular night, the temperature had apparently dropped low enough that Nathaniel had not awakened. Or perhaps he had awakened, but had been too cold to move effectively, his body already shutting down. There was no way to know. What Enoch did know, with absolute certainty, was that the same thing could happen to him. Any night, if the fire died and the temperature dropped far enough, he might simply not wake up. The cabin provided shelter from wind and precipitation, but it did not provide reliable protection from extreme cold. The heat from the fireplace radiated outward for a few feet and then dissipated. The walls offered minimal insulation. The entire structure was fundamentally dependent on maintaining an active fire. That dependency, Enoch realized, was the problem, and problems could be solved. Enoch spent the next 3 weeks completing the season's trapping work alone. He checked the trap lines Nathaniel had set, processed the pelts they had already taken, and maintained the camp. The work was mechanical and gave him time to think. He thought constantly about heat, about cabins, about the fundamental relationship between fire and survival in winter conditions. He began conducting experiments. On clear nights, he would build the fire to a specific size, let it burn down to coals, and then measure how quickly the cabin cooled. He used a thermometer he had purchased 2 years earlier at Fort Laramie, an expensive instrument he had bought primarily out of curiosity. Now it became a tool for systematic observation. He would place the thermometer at various locations in the cabin and record temperatures. Near the fireplace, the temperature might reach 70 degrees. 6 feet away, it dropped to 50. Along the walls, it fell to 40 or below. This was with an active fire burning. When the fire died completely, temperatures dropped rapidly. Within 2 hours, the interior of the cabin would match the exterior temperature almost exactly. The logs provided virtually no insulation. The gaps between them, despite the chinking, allowed cold air to infiltrate continuously. The roof, while adequate for keeping out rain and snow, did nothing to prevent heat loss upward. Enoch began paying attention to how other trappers heated their cabins. He visited 3 camps within a day's travel of his location. Every cabin was essentially the same. Stone or mud fireplace in one corner, fire burning constantly during cold weather, men clustering near the heat source. Everyone accepted this as the only possible arrangement. You built a fire, you sat near it. When you slept, you hoped the fire lasted through the night. If it did not, you hoped you woke up in time to rebuild it before the cold became dangerous. The inefficiency offended him. A fire burning in a fireplace produced enormous amounts of heat. He could feel it radiating from the flames. Yet most of that heat went directly up the chimney and out into the open air. The stone or mud surrounding the fireplace absorbed some heat and radiated it back into the room. But this was a small fraction of the total. The vast majority of the energy released by burning wood was simply wasted. Enoch had no formal education in thermodynamics or engineering. He understood fire the way any frontiersman did, through practical experience. Wood burned, produced heat and smoke. The smoke went up the chimney, the heat warmed whatever was nearby. That was the extent of most men's understanding. But Enoch began thinking about the smoke. Smoke was hot. He could feel the heat rising from the fire. That hot smoke carried energy up the chimney and released it into the winter air above the cabin. What if there was a way to capture that heat before it escaped? What if the smoke could be routed through a longer path, forced to give up its heat inside the cabin before being allowed to exit? December brought heavier snow and colder temperatures. Enoch continued trapping, working his lines alone, surviving. He had enough supplies to last through winter, and enough pelts to make the season profitable if he could transport them to market in spring. But his mind remained fixed on the heating problem. He spent evenings sketching ideas on pieces of bark using charcoal from the fire. Most of the ideas were impractical or impossible with available materials. He drew chimneys that zigzagged through cabin walls. He sketched enclosed fireboxes with multiple chambers. Nothing seemed workable. In mid-December, a German immigrant named Gunther Reinhold stopped at Enoch's cabin. Gunther was not a trapper, but a wandering laborer who did masonry work, stone cutting, and general construction. He traveled between frontier settlements and military posts, taking whatever jobs were available. He was perhaps 50 years old, spoke heavily accented English, and had spent his youth in Bavaria working on large buildings. He was heading toward Fort Laramie for the winter and stopped seeking a night's shelter and a meal. Enoch offered both willingly. Frontier hospitality was not optional. Men helped each other because someday they would need help themselves. They shared the evening meal, venison stew and coffee, and talked. Gunther asked about Nathaniel. Enoch explained what had happened. The older man nodded grimly. He had seen men freeze to death before. It was common enough. The conversation turned to construction and heating. Enoch, hungry for any knowledge that might apply to his problem, asked Gunther about buildings in Europe. How did they heat large stone structures? Gunther described various systems. In wealthy homes, there were tile stoves, massive ceramic structures that burned wood in an enclosed firebox and radiated heat for hours. In some regions, there were systems where hot air from fires was directed through channels in walls or under floors. He mentioned Roman ruins he had seen in southern Germany, ancient buildings with raised floors supported by small pillars, spaces beneath where hot air from furnaces had once circulated. Enoch stopped him. Hot air under floors? How did that work? Gunther explained as best he understood it. The Romans had built furnaces outside, their bathhouses and wealthy homes. The hot exhaust from these furnaces was directed into chambers beneath raised floors. The stone floors absorbed the heat and radiated it upward into the rooms above. The exhaust eventually escaped through flues in the walls. The system, called a hypocaust, allowed even heating of large spaces. Gunther had seen the remains of such systems in archaeological sites. They had worked for centuries. Enoch asked more questions. Could such a system be built in a log cabin? Gunther shrugged. He supposed anything was possible if a man had time and materials. The principle was simple. Route hot air through a longer path before letting it escape. Use stone or earth as thermal mass to absorb and hold heat. But it would require significant construction work. Most trappers would consider it insane to attempt. Spring came late in 1840. Enoch broke camp in early April and made the 3-week journey to Fort Laramie with his winter's catch of pelts. The take was modest but sufficient. He sold the furs to a trading company agent and received payment in coin and credit. Most trappers would have spent the money on whiskey, gambling, and supplies for the next season. Enoch spent 2 days walking through the fort's trading post and blacksmith shop, making a list. He purchased items that made the clerk suspicious. 2 sections of iron stovepipe, each 4 feet long and 8 inches in diameter. A set of stone-cutting chisels, 3 bags of lime for making mortar. A second thermometer to verify measurements against his first. heavy canvas, 20 pounds of square-cut nails. The clerk asked what he was building. Enoch said he was improving his cabin. The clerk commented that it must be some improvement given the unusual supplies. Enoch did not elaborate. He also spent time in the fort's small library, a collection of perhaps 200 books maintained by the post commander, an educated man from Philadelphia. Enoch was not a strong reader, but he had basic literacy and could work through technical texts if they were clearly written. He found a surveying manual that included sections on foundation construction and drainage. He found a military engineering handbook that discussed fortification heating systems. He spent 3 days reading and taking notes on more pieces of bark. The concept forming in his mind was becoming clearer. He would route the hot exhaust from his fireplace through a channel beneath the cabin floor before allowing it to exit. The channel would be constructed from stone, buried in the earth. As hot smoke and air passed through this underground passage, the stone would absorb heat. The earth surrounding the stone would absorb heat. The wooden floor above the buried channel would be warmed from below. Instead of all the heat escaping directly up the chimney, much of it would be transferred into the thermal mass beneath the cabin, which would radiate warmth upward for hours. The challenges were significant. He would need to excavate beneath his existing cabin floor or build an entirely new cabin with the system integrated from the start. He would need to construct an airtight channel that would draw smoke effectively without leaking into the living space. He would need to calculate the length and routing of the underground passage to maximize heat transfer without choking off the draft that made the fireplace function. He would need to do all of this alone, without help, because he knew no one would believe the idea was workable. Enoch returned to his camp in late April. He spent May and early June finishing the spring trapping season and preparing for construction. He cut and hauled stones from a rocky outcrop 2 miles away. He felled trees and stripped bark, selecting logs for structural repairs. He dug clay from a riverbank and mixed experimental batches of mortar. By late June, he was ready to begin the most ambitious construction project any trapper in the territory had ever attempted alone. Enoch began work on July 1, 1840. The summer weather was ideal for construction, warm days and cool nights. He started by removing the furniture from his cabin and taking up the floorboards. The boards were rough-hewn planks laid across log joists, not nailed, but simply placed. He stacked them outside, planning to relay them once the underground work was complete. With the floor removed, he faced bare earth packed hard from months of foot traffic. He marked out his excavation path using stakes and cord. The trench would run from the fireplace corner across the length of the cabin, a distance of roughly 14 feet, then turn and exit through the wall. The route was as direct as possible while staying clear of the foundation logs. He calculated that a trench 2 feet deep and 2 feet wide would provide sufficient space for the stone duct, with earth packed around it for insulation and thermal mass. The digging was brutal work. The earth was dense and filled with rocks. He used a pickaxe to break the ground, then shoveled out the loose material. Progress was measured in inches per hour. By the end of the first day, he had excavated perhaps 3 feet of trench. At that rate, the digging alone would take 2 weeks. He settled into a routine: dig from dawn until midday, rest during the afternoon heat, dig again in the evening until dark. His hands blistered, then calloused. His back ached constantly. Absalom Pritchard visited during the second week. Absalom was a trapper who worked territory about 8 miles north of Enoch's camp. He was 41 years old, had been in the mountains for a decade, and considered himself an expert on frontier survival. He stood at the cabin door looking at the excavated trench and shook his head. "What in God's name are you doing, Winslow?" Enoch explained the concept. Hot smoke from the fireplace would travel through an underground stone channel before exiting, warming the earth and floor. Absalom listened with increasing disbelief. You're tearing up a perfectly good cabin to bury rocks under the floor? For what purpose? The fireplace already heats the place." "Not efficiently," Enoch said. "Most of the heat escapes unused." "Heat is supposed to go up," Absalom replied. "That's how chimneys work. You trying to reverse nature?" He laughed. "You've been alone too long, Winslow. This is madness. You'll ruin your cabin and accomplish nothing. Smoke goes up chimneys, not through underground tunnels." Enoch returned to digging without responding. Absalom watched for a few more minutes, then left, shaking his head. Over the following weeks, other trappers stopped by. Word had spread through the scattered community that Enoch Winslow had lost his mind and was destroying his cabin for some insane purpose involving rocks and tunnels. Some came out of curiosity. Others came to offer advice, suggesting he stop before he made things worse. A few came simply to witness the spectacle of a man wasting an entire summer on foolishness. Enoch ignored them all. By late July, the trench was complete. 2 feet deep, 2 feet wide, running 14 feet across the cabin, and then 6 more feet to exit through the wall. He had removed approximately 40 cubic feet of earth, all excavated by hand, working alone. With the excavation complete, Enoch began constructing the actual heat duct. His design called for a rectangular channel built from flat stones, essentially a horizontal chimney buried beneath the floor. The channel needed to be large enough to allow smoke and hot air to flow freely, but not so large that the draft would be inadequate. He settled on interior dimensions of roughly 10 inches wide by 12 inches high. He started at the fireplace end. The first challenge was creating the transition from the vertical fireplace throat down into the horizontal underground channel. He accomplished this by modifying the back of his existing fireplace, removing several stones, and creating an opening at floor level. From this opening, he built a sloped stone transition that descended into the trench. The duct itself was constructed from flat river stones mortared together. Enoch had spent weeks gathering stones of appropriate size and shape, selecting pieces that could be fitted together like masonry. He laid a foundation of larger stones at the bottom of the trench, then built up the side walls using progressively smaller pieces. Each stone was set in lime mortar, the joints carefully packed to prevent smoke leakage. The work required precision. If the joints were not tight, smoke would escape into the earth and eventually seep up into the cabin. He worked section by section, building 3 feet of channel, letting the mortar cure for 2 days, then building the next section. The process was methodical and slow. Each 3-foot section required approximately 50 stones, individually selected, shaped if necessary using his chisels, then set in place. The mortar had to be mixed fresh for each work session, combining lime, sand, and water. In proportions he had learned from watching Gunther Reinhold work. The top of the channel was formed using larger flat stones laid across the side walls, creating a roof over the passage. These capstones had to be carefully selected for size and strength. They would bear the weight of earth backfill and the floor above. Enoch tested each capstone before setting it, ensuring it could support his full weight without cracking. Once the capstones were in place and mortared, each section of duct was complete and airtight. By mid-August, he had completed the main run of duct from the fireplace transition to the point where the channel would turn toward the exit. The construction had consumed 6 weeks. Every section had to be perfect. A single gap could allow smoke to leak, ruining the entire system. Jedediah Talmadge visited in late August. Jedediah was 63 years old, a former military scout who had been in the mountains since 1815. He examined the stone duct with the eye of a man who had seen many forms of frontier construction. "It's well built," he admitted, "but I don't see how it will work. Smoke rises, Winslow. It doesn't travel horizontally underground." "It will if there is sufficient draw," Enoch replied. "The principle is the same as any chimney. Hot air rises, creating draft. The draft pulls smoke through whatever path is available." Jedediah shook his head. You've wasted a summer on a theory. The turn in the duct presented the most difficult construction challenge. Enoch needed to redirect the flow 90 degrees, from running parallel to the cabin's length to heading perpendicular toward the exit point in the wall. A sharp right angle would create turbulence and potentially choke off the draft. He needed a gradual curve that would maintain smooth airflow while fitting within the constraints of his excavation. He solved this by building the turn as a series of angled sections rather than a true curve. Each section was offset slightly from the previous one, creating a stepped transition that approximated a curve. The interior of the turn was lined with smaller, carefully shaped stones to eliminate sharp edges where smoke might eddy and deposit creosote. The entire turn section took a week to construct and required stones of unusual shapes that he had to search for specifically or chip to fit. Beyond the turn, the duct continued in a straight line toward the exterior wall. This final section was 6 feet long and functioned as the last opportunity to extract heat before the exhaust exited. Enoch built it to the same specifications as the main run, maintaining consistent cross-sectional area to preserve draft. He paid particular attention to the joints in this section, knowing that any smoke leakage near the wall could cause structural problems. The exit point required careful engineering. Enoch cut through the cabin's log wall at floor level, creating an opening just large enough for the duct to pass through. He extended the stone channel through the wall and 2 feet beyond, creating an exterior termination point. The exit faced downwind, based on prevailing wind patterns, and he built a simple stone cap over the opening to prevent rain and snow from entering while allowing smoke to escape freely. With the duct complete from fireplace to exit, Enoch began ensuring the entire system was airtight. He inspected every joint, every seam, every transition point. Any gap would allow smoke to escape into the surrounding earth, reducing efficiency and potentially creating dangerous conditions. He applied additional mortar to suspicious joints and waited for everything to cure completely. This patience was essential. Wet mortar would crack when exposed to heat. He gave the entire system 2 weeks to dry and harden before proceeding. While the mortar cured, Enoch prepared for the next phase, backfilling the trench around the completed duct. The backfill material was critical to the system's performance. He hauled clay from the riverbank and mixed it with sand and small stones, creating a dense mixture that would pack solidly around the duct and absorb heat efficiently. He backfilled carefully, packing the clay mixture tightly against all sides of the stone duct. The goal was to eliminate air pockets that would insulate rather than conduct heat. He worked in layers, adding 6 inches of material, tamping it down firmly with a wooden pole, then adding another layer. The process took 3 days and consumed approximately 30 cubic feet of clay mixture. When complete, the duct was buried in dense thermal mass that would absorb and store heat from the passing smoke. The final layer of backfill was clean sand, packed over the clay to create a level surface for the floor. Enoch used a straight edge to ensure the sand layer was uniform, providing stable support for the floorboards. With the underground duct complete and buried, Enoch turned his attention to perfecting the fireplace connection. The transition from vertical firebox to horizontal underground channel was the most critical junction in the entire system. If this connection failed to create adequate draft, smoke would back up into the cabin, making it uninhabitable. His modified fireplace now had 2 potential paths for smoke. The original chimney still rose vertically from the firebox. The new path descended through the back of the firebox into the underground duct. He fabricated a damper from a flat piece of iron purchased at Fort Laramie. The damper pivoted on an iron pin, allowing him to close off the vertical chimney and force all exhaust through the underground path, or open the chimney and bypass the underground system entirely. The damper mechanism was crude but functional. A rod extended from the damper plate through the side of the firebox, where Enoch could adjust it from outside. different positions would allow him to tune the system's performance based on weather conditions and fire size. On extremely cold days, he could force all exhaust through the underground duct for maximum heat extraction. On mild days, he could partially bypass the system to prevent overheating. He tested the damper operation repeatedly before lighting any fire. He greased the pivot pin with animal fat and ensured the rod moved smoothly. The damper plate was heavy enough to stay in position once set, but light enough that he could adjust it with one hand. With the damper installed, Enoch was ready for the first test fire. It was September 3, 1840. He had been working on the system for 2 months. He built a small fire using dry kindling and larger pieces of pine. He positioned the damper to send all exhaust through the underground duct and closed off the vertical chimney completely. Then he lit the kindling and stepped back. For the first 30 seconds, smoke filled the firebox and began spilling into the cabin. Then suddenly, the smoke reversed direction and began flowing smoothly into the fireplace. Within a minute, the draft had established itself. Smoke was being pulled down into the underground duct and traveling the full length of the buried channel before exiting. He went outside and checked the exterior exit point. Thin smoke was emerging steadily from the stone opening beyond the wall. The system worked. Hot exhaust was flowing through 20 feet of buried stone channel instead of going straight up a chimney. Enoch returned inside and placed his hand on the floor above the duct. Within 10 minutes, he could feel warmth. Within 30 minutes, the floorboards were noticeably warm to the touch. Within an hour, the entire floor surface radiated heat. He ran the test fire for 3 hours, monitoring temperatures and checking for smoke leakage. No smoke escaped into the cabin. The draft remained strong throughout. When he let the fire die down, the floor remained warm for over 2 hours afterward, proving the thermal mass was storing and slowly releasing heat exactly as intended. The initial test proved the concept, but Enoch knew the system required refinement. The exit vent's position and design would determine how efficiently the entire system operated. Too much draft would pull heat through the duct too quickly, preventing adequate thermal transfer. Too little draft would cause smoke to back up. He needed to find the optimal balance. The current exit vent sat 2 feet beyond the exterior wall at ground level. Enoch observed its performance over several days of testing. The draft was adequate but inconsistent. When wind blew from certain directions, it created back pressure that reduced flow. When air was completely still, the draft weakened. He needed a design that would maintain consistent draw regardless of weather conditions. He extended the exit vent upward, building a short stone chimney that rose 3 feet above ground level. This elevation helped. The vertical rise created additional draft through stack effect, and the height reduced wind interference. He capped the chimney with a flat stone set on smaller support stones, creating a simple rain cover that still allowed smoke to escape from all sides. Testing resumed. Enoch burned fires of varying sizes and monitored how quickly heat transferred to the floor. With larger fires, the floor warmed rapidly, but the exhaust at the exit point remained very hot, indicating incomplete heat extraction. With smaller fires, the floor took longer to warm, but the exhaust exited much cooler, proving better heat transfer. The relationship was clear. Slower flow meant more heat extraction. He added a second damper at the exit point, a simple iron plate that could partially restrict the opening. This gave him control over draft speed. By adjusting both the fireplace damper and the exit damper, he could tune the system precisely. On very cold days requiring maximum heat, he would restrict the exit damper slightly, slowing the exhaust flow and forcing more heat into the thermal mass. On milder days, he would open it fully for faster flow and less heat retention. The positioning of both dampers required experimentation. Too much restriction caused smoke to back up into the cabin. Too little restriction meant wasted heat. Enoch spent 2 weeks testing different combinations, recording the results with his thermometers. He measured floor temperature, exhaust temperature at the exit, and interior air temperature at various locations in the cabin. He discovered that optimal performance came from moderate restriction at both points. The fireplace damper set to allow 60% of exhaust through the underground path, 40% up the standard chimney. The exit damper partially closed to slow the underground flow. This configuration extracted maximum heat while maintaining reliable draft. The floor above the duct would reach temperatures of 90 to 100 degrees. When the fire burned steadily, the surrounding floor areas, warmed by conducted and radiated heat, reached 70 to 80 degrees. The entire cabin benefited from the distributed warmth rising from below. With the underground system functioning reliably, Enoch began restoring the cabin floor. The floorboards had been stacked outside for 3 months, exposed to summer weather. He inspected each plank carefully, discarding several that had warped or cracked. He would need to cut replacement boards from logs he had set aside for this purpose. Before relaying the floor, he made one additional modification to the system. Between the packed sand layer and the floorboards, he installed a thin layer of flat stones. These stones would serve as a secondary thermal mass, absorbing heat from the earth below and radiating it upward more efficiently than wood alone. The stones were carefully selected, river rocks, flat and uniform in thickness, laid in a single continuous layer across the entire floor area. The stone layer added thermal mass directly beneath the living surface. Wood conducted heat poorly. Stone conducted it well. By placing stone immediately below the floorboards, heat from the buried duct would transfer more efficiently to the cabin interior. The stones also provided additional support for the floor, distributing weight more evenly than the original earth and joist system. Laying the floor took a week. Enoch worked methodically, placing each board with care. The original floor had simply rested on joists. This time, he nailed the boards in place using the square-cut nails purchased at Fort Laramie. Nailing prevented the boards from shifting and created a more solid, permanent surface. He left small gaps between boards for expansion and contraction with humidity changes. When the floor was complete, the cabin looked normal again. No visible evidence remained of the extensive underground construction. Only someone who knew what lay beneath would understand that the floor was not simply supported by earth and joists, but instead rested on a sophisticated thermal system of stone ducts, clay backfill, and secondary thermal mass. Enoch replaced the furniture. His sleeping platform went back against the wall. The table returned to the center of the room. His single chair, which had stood near the fireplace for 6 winters, he placed deliberately against the opposite wall, 12 feet from the fire. It was an experiment and a statement. The system was complete. Construction had consumed 4 months. From early July through late October, Enoch had worked nearly every day, excavating, building, testing, and refining. The physical labor had been extreme. The technical challenges had been significant. The social cost had been real, with neighbors convinced he had wasted an entire season on a delusional project. But the system worked. He had proven it through weeks of testing. The underground heat duct extracted warmth from exhaust that would otherwise escape unused. The thermal mass stored that heat and released it slowly over hours. The floor radiated warmth upward into the entire cabin space. On paper and in practice, the engineering was sound. Now winter would provide the real test. Not controlled fires for measurement purposes, but sustained heating through months of extreme cold. The system would either perform as designed or fail catastrophically. There would be no middle ground. November brought the first snow. Light accumulation at first, then heavier storms as the month progressed. Temperatures dropped steadily. By mid-November, nighttime lows were reaching 0 degrees. Daytime highs struggled to rise above 20. The Montana winter was establishing itself with characteristic severity. Enoch began heating his cabin in earnest. Each evening he built a fire sized to provide steady heat through the night. He adjusted the dampers to his tested optimal settings, sending most of the exhaust through the underground duct while maintaining enough vertical draft to prevent smoke backup. The system performed exactly as his testing had predicted. The difference from previous winters was dramatic. In past years, he would build a large fire and huddle near it. The area immediately around the fireplace would be warm, perhaps even hot. 6 feet away, temperatures would drop noticeably. Along the walls, the cold was tangible. At night, if the fire died, the cabin would become dangerously cold within 2 hours. Now, with the underground system operating, the entire floor radiated heat. Standing anywhere in the cabin, Enoch could feel warmth rising from below. The sensation was fundamentally different from radiant heat from a fire. Instead of warmth coming from one direction, it rose evenly from the entire floor surface. The walls, warmed by rising air, stayed significantly warmer than exterior temperatures. Most remarkably, when the fire died down overnight, the cabin remained warm for hours. The thermal mass beneath the floor stored enough heat to continue warming the space long after flames ceased. Enoch would wake in the morning to a cabin that was still comfortably warm, not the desperate cold of previous winters. He would rebuild the fire from coals, not from scratch, saving time and effort. He conducted measurements. With an active fire burning at moderate intensity, interior air temperature 6 feet from the fireplace measured 68 degrees. The floor surface temperature above the underground duct measured 92 degrees. The wall temperature measured 54 degrees. These were extraordinary numbers compared to conventional cabins. But quantified success meant nothing if neighbors remained skeptical, and they did. Absalom Pritchard visited in late November and examined the restored cabin. "Looks the same as before you tore it apart," he observed. "Was all that work worth it?" "Stand on the floor away from the fire," Enoch said. Absalom did so, positioning himself 8 feet from the fireplace. After a moment, his expression changed. "The floor is warm." "The entire floor is warm," Enoch replied. "And the warmth lasts for hours after the fire dies. I use half the wood I used last winter, and the cabin stays warmer." Absalom was skeptical, but could not deny what he felt through his boot soles. Still, he was not convinced. "One mild winter doesn't prove anything. Wait until we get real cold. Then we'll see if your underground rocks work as well as you claim." Real cold was coming. Enoch could feel it in the air. December would bring the season's first true test. December arrived with brutal temperatures. On the 5th, the mercury dropped to 18 degrees below zero overnight. On the 7th, it reached 23 below. These were dangerous conditions. Men had frozen to death in adequately built cabins during cold snaps like this. The conventional wisdom was to keep fires burning constantly, feed them heavily, and hope the wood supply lasted. Enoch maintained his normal routine. Each evening, he built a moderate fire, adjusted his dampers to optimal settings, and let the system work. The underground duct heated steadily. The thermal mass absorbed and stored warmth. The floor radiated heat upward. By midnight, when he went to sleep, the cabin interior measured 65 degrees despite exterior temperatures of 20 below zero. He woke at dawn. The fire had burned down to coals. Outside, the temperature had dropped to 26 below zero. Inside, the cabin measured 58 degrees. Still comfortable, still safe. The thermal mass beneath the floor had released stored heat throughout the night, maintaining livable temperatures even with minimal fire. He rebuilt the fire from coals, and within 30 minutes the cabin was fully warm again. The wood consumption was significant, but not excessive. Enoch estimated he was burning approximately 60% of the wood he had burned during previous winters, achieving better results. The efficiency came from heat extraction. Every bit of warmth that previously escaped up the chimney now warmed the thermal mass beneath his floor. Other trappers were not faring as well. Enoch saw smoke from Absalom Pritchard's cabin throughout the day and night. indicating constant heavy fires. He encountered Levi Burnham at a creek while checking ice conditions. Levi looked exhausted. "Haven't slept properly in days," he admitted. "Have to wake every 2 hours to feed the fire. If it dies, the cabin gets cold enough to kill us." Levi and his wife Temperance had a cabin 6 miles south. They had 3 young children. Keeping the family safe through winter required constant vigilance. Levi was burning through his wood supply at an alarming rate, and the worst of winter had not yet arrived. "How are you managing?" Levi asked. "I see smoke from your chimney, but not as much as I would expect for cold like this." Enoch explained briefly about the underground heat duct system. Levi listened with tired skepticism. "Rocks under the floor keeping you warm? That sounds like fantasy." "Come see for yourself," Enoch offered. Levi shook his head. "No time. Have to get back to keep the fire going." He trudged away through the snow, a man trapped in an exhausting cycle of survival. The cold snap lasted 12 days. When it finally broke and temperatures rose to a merely frigid 10 degrees above zero, Enoch had survived comfortably while his neighbors had suffered. But suffering was not proof. Skeptics could argue he had been lucky, or that his cabin was better insulated, or that he was exaggerating his comfort. They needed undeniable demonstration. They needed numbers. January 1841 brought the coldest weather anyone in the territory could remember. The temperature dropped and stayed down. For 3 solid weeks, daytime highs never rose above zero. Nighttime lows reached 40 degrees below zero on multiple occasions. Snow fell intermittently, adding to accumulations already measured in feet. Travel became nearly impossible. Men stayed in their cabins, burning wood, rationing food, and enduring. Enoch's system performed flawlessly. He maintained a steady routine of moderate fires, allowing the underground duct to heat the thermal mass, which in turn warmed the cabin for extended periods. His wood consumption remained reasonable. He estimated his supply would last through March without difficulty. The cabin stayed consistently warm, not just near the fireplace, but throughout the entire space. The chair positioned 12 feet from the fireplace became a daily reminder of the system's effectiveness. Enoch would sit there in the evenings, comfortable in his shirt sleeves, while outside the temperature hovered at 30 below zero. The floor beneath his feet radiated steady warmth. The walls, heated by rising air, never developed the brutal interior cold that characterized conventional cabins in extreme weather. Other settlers struggled desperately. Absalom Pritchard burned through his primary wood supply by mid-January and began cutting into reserves he had planned to save for late winter. His cabin required constant attention. The fire could not be allowed to die or even diminish significantly without dangerous temperature drops. He slept in short intervals, waking repeatedly to add wood. Levi Burnham faced worse conditions. With a wife and children depending on him, he could not risk the fire dying during the night. He and Temperance took turns staying awake, feeding the fire every hour. Their wood supply dwindled at an alarming rate. By late January, Levi was cutting and hauling timber daily despite the extreme cold, an exhausting and dangerous task in such weather. On January 23rd, Jedediah Talmadge stopped at Enoch's cabin while traveling between camps. Jedediah was checking on various trappers, ensuring no one had frozen or run into serious trouble. He entered Enoch's cabin and immediately noticed the warmth. "You're burning a lot of wood to keep it this comfortable." "Normal amount," Enoch replied. "Less than last winter, actually." Jedediah frowned. He walked around the cabin holding his hands near the walls. "These walls are warm. Absalom's walls are ice cold inside, even with his fire roaring constantly." He looked at Enoch with new respect mixed with confusion. "Your underground system is actually working." "It works," Enoch confirmed. Jedediah studied the floor, the fireplace, the simple chair positioned far from the heat source. "I owe you an apology. We thought you were wasting your time. Building rocks under your floor seemed like madness." He paused. "Men are suffering out there. Levi's family is barely making it. His children are cold constantly. His wife looks exhausted. Enoch had heard similar reports. The winter was testing everyone. Those with adequate wood and strong cabins would survive. Those without might not. I can explain the system to anyone who asks. They'll ask, Jedediah said. After this winter, they'll definitely ask. February 3rd brought slightly warmer weather, temperatures rising to 10 degrees above zero. Jedediah Talmage returned to Enoch's cabin with Absalom Pritchard and his thermometer. Absalom had finally agreed to see Enoch's system in action and verify the claims with measurements. The three men stood inside Enoch's cabin. A moderate fire burned in the fireplace, nothing excessive. The interior was comfortable. Absalom removed his heavy coat immediately. "It's warm in here." "Measure it," Jedediah suggested, handing Absalom the thermometer. Absalom held the thermometer at chest height in the center of the cabin, 8 feet from the fireplace. They waited 3 minutes for an accurate reading. The mercury settled at 67 degrees. Absalom moved to the wall farthest from the fire and held the thermometer against the interior log surface. After 2 minutes, it read 52 degrees. "That's impossible," Absalom said. "My cabin walls are freezing even right next to the fire." Enoch knelt and placed his palm on the floor. "Feel this." Absalom knelt and touched the floorboards. They were distinctly warm, not hot, but noticeably above air temperature. "The floor is heated?" "The entire floor," Enoch confirmed. "The underground duct heats the thermal mass beneath. The mass radiates upward through the stone layer and floorboards. The rising heat warms the whole cabin, including the walls." They discussed the system's construction and operation. Jedediah asked technical questions about draft, smoke flow, and heat transfer. Absalom remained skeptical of the explanation, but could not argue with the measured temperatures. Finally, Jedediah made a suggestion. "We should measure Absalom's cabin for comparison. Same time, same weather, both cabins with similar fires burning." They walked to Absalom's cabin, a quarter-mile away. Inside, Absalom had maintained a large fire that consumed substantially more wood than Enoch's moderate blaze. The area immediately around the fireplace was hot. Absalom, Jedediah, and Enoch stood in the center of the cabin, 8 feet from the flames. The thermometer read 48 degrees. "That's 19 degrees colder than Enoch's cabin," Jedediah observed. They moved to the exterior wall. Jedediah held the thermometer against the interior log surface. After 2 minutes, it read 16 degrees, barely above freezing despite the large fire burning just feet away. Absalom stared at the measurement. The difference was undeniable. Enoch's cabin wall had measured 52 degrees. His own measured 16 degrees. The difference was 36 degrees. Both cabins were similar construction. Both had fires burning. Enoch's cabin was dramatically warmer with less wood consumption. 52 degrees, Absalom said quietly. "Your walls are 52 degrees warmer than mine." The number hung in the cold air. It was not a matter of opinion or subjective comfort. It was measured, verified, undeniable fact. Enoch's underground heat duct system was maintaining interior wall temperatures 52 degrees higher than conventional cabin heating while using less fuel. Absalom stood silent for a long moment. Finally, he looked at Enoch. "I need you to show me how you built it." News of the measurement spread through the scattered trapping community. 52 degrees warmer became the phrase everyone repeated. Men who had mocked Enoch's summer construction project now reconsidered, but considering and acting were different things. Most trappers were focused on immediate survival, not construction projects that would require tearing apart their cabins. Levi Burnham had reached his breaking point. By mid-February, his wood supply was nearly exhausted. His family was cold constantly despite his best efforts. His children were showing signs of prolonged cold exposure, lethargic and withdrawn. Temperance had developed a persistent cough. The situation was becoming dangerous. On February 19th, Levi appeared at Enoch's cabin. He looked exhausted, desperate. I need help. My family can't survive the rest of winter like this. We're out of wood. The children are suffering," he paused. "Jedediah told me about your measurements. 52 degrees warmer. Is that real?" "It's real," Enoch confirmed. "Come inside." Levi entered and immediately felt the difference. The warmth was pervasive, not concentrated near the fare. He knelt and touched the floor. "This is warm. How?" Enoch explained the system completely. The underground stone duct, the thermal mass of clay and earth, the damper controls, the extended heat extraction. He showed Levi the exterior exit point where smoke emerged after traveling through 20 feet of buried channel. He explained the construction process, the challenges, the solutions. Levi listened intently. Could this be built in an existing cabin, like mine? Yes, that's what I did. Excavated beneath the existing structure, built the duct, restored the floor. It took 4 months working alone. With 2 men, it could be done faster. "I don't have 4 months, Fisa," Levi said. "Winter is half over, but I can't make it through the other half. My family can't." Enoch considered. Levi's cabin was 6 miles away. Building a complete system there would require weeks of work in brutal cold, but the alternative was watching a family freeze. "I'll help you build it. We'll work as fast as weather allows. You'll need to gather stones and clay while I'm not there. We'll need more lime for mortar." Levi's relief was visible. "I'll do whatever you tell me. Gather whatever materials you need. Just help us survive this winter." They began the next day. Enoch brought tools and his remaining lime supply to Levi's cabin. They started excavating despite temperatures hovering near zero. The work was brutal in winter conditions. The frozen earth required hours of pickwork to loosen. Their hands grew numb despite heavy gloves, but they continued because the alternative was unacceptable. Temperance and the children moved in with neighbors while construction proceeded. The Burnham cabin became a work site, floor torn up, earth excavated, stones gathered and shaped. Levi proved to be a capable worker, following Enoch's instructions precisely, understanding the principles once explained. They worked from dawn to dusk, every day weather permitted. The Burnham cabin's underground heat duct system was completed in 5 weeks. Construction in winter conditions took longer than summer work, but desperation drove efficiency. By late March, the system was operational. Levi's family returned home to a transformed cabin. The difference was immediate and dramatic. For the first time all winter, the children played on the floor comfortably. Temperance's cough began improving within days as the constant cold stress ended. Word spread faster than Enoch anticipated. Simeon Blackburn, a traveling merchant who supplied the scattered trapping community, stopped at the Burnham cabin in early April. He felt the warm floor, heard the explanation, and understood the implications. Settlements throughout the territory struggled with winter heating. A proven solution would interest many people. Simeon asked detailed questions about construction methods, materials, and costs. He took notes. "This could change how people build in cold country," he said. "Mind if I tell others about what you've done?" "Tell anyone you want," Enoch replied. "I'm not keeping secrets. If the system helps people survive winters, that's good." By late April, as spring thaw began, 3 more trappers approached Enoch requesting help building underground heat duct systems. He agreed to assist each one, teaching them the construction principles so they could complete much of the work themselves. The basic concept was simple enough. Route hot exhaust through buried stone channels, surround the channels. With thermal mass, let the floor become a radiant heating surface. The execution required precision, but motivated men could learn. Throughout the spring and summer of 1841, Enoch worked on various cabin projects across the region. Some were new construction, with the heating system integrated from the beginning. Others were retrofits like his own, requiring careful excavation beneath existing structures. Each project refined his understanding of optimal design. He learned which shortcuts worked and which compromised performance. He developed faster construction methods and better material choices. The systems he helped build all functioned successfully. Some performed better than others depending on construction quality, but even poorly executed versions provided dramatic improvement over conventional heating. The fundamental principle was sound. Extract heat from exhaust before it escapes. Store that heat in thermal mass. Distribute it evenly through radiant floor. Warming. By autumn, several dozen cabins in the Montana and Wyoming territories featured underground heat duct systems. The technique had acquired a name in the scattered settlements. Trappers and settlers called it Winslow heating, named after the man who had proven it worked through a winter that killed men in conventional cabins. Enoch had not sought credit or attempted to profit from his innovation. He had simply solved a problem that had killed his partner, then shared the solution with anyone interested. The winter of 1841 to 1842 was mild compared to the previous year, but the improved cabins performed well. Men who had spent previous winters in constant struggle with cold now lived comfortably. Families stayed warm without exhausting wood supplies. The mortality rate in equipped cabins dropped to essentially zero for cold-related deaths. Enoch continued trapping through 1842 and 1843, but the fur trade was clearly ending. Beaver populations were depleted. Eastern markets had moved on to other materials. Smart men were leaving the mountains for Oregon or California. In the spring of 1847, Enoch Winslow left the Montana Territory for the last time. He was 40 years old and had spent 14 years in the mountains. The fur trade was finished. Most of the trappers he had known were gone, dead, or moved on. He packed his remaining possessions onto 2 horses and rode west toward Oregon Territory, where land was available under new settlement laws. He established a small farm in the Willamette Valley, married a widow named Catherine in 1849, and lived quietly. He raised crops, kept livestock, and participated in the growing community. He never spoke much about his trapping years. When neighbors asked about his past, he mentioned the mountains, but avoided details. The underground heating system he had built was not part of the stories he told. Enoch died in February 1869 at age 62. The cause was pneumonia following a winter cold. He was buried in a small cemetery outside Salem. His gravestone listed his name, birth and death years, and nothing else. His wife and stepchildren knew him as a farmer, not as the man who had changed frontier heating. But in the mountains of Montana and Wyoming, structures remained. The cabin Enoch had built in 1839 stood abandoned but intact. The underground heat duct system, unused for years, was still structurally sound. The stone channels remained airtight. The thermal mass, though cold, retained its capacity to store and radiate heat. Settlers moving through the area occasionally sheltered in the old cabin and marveled at the warm floor when they built fires. Other cabins built using Enoch's methods continued serving new inhabitants. Some were maintained and occupied for decades. The technique spread beyond the original region as people moved and shared knowledge. By the 1850s, variations of underground heat duct systems appeared in Montana, Wyoming, Idaho, and even parts of Dakota Territory. Not every builder understood the principles completely, but the basic concept persisted. Root exhaust through buried channels. Use thermal mass for heat storage. Warm the floor to heat the entire structure. The phrase Winslow heating faded from use as the technique became standard practice in certain regions, but the innovation endured. Frontier historians estimate the system saved dozens of lives over subsequent decades. Men, women, and children survived winters that would have killed them in conventional cabins. Most never knew the name of the man who had developed the method that kept them alive. Enoch Winslow proved that the most valuable frontier innovations were not weapons or tools, but better methods for fundamental survival. A trapper who learned to capture wasted heat solved one of wilderness life's most dangerous problems. His solution required no new technology, just existing materials used with intelligence and care. That solution, shared freely, became his legacy, not carved in monuments or recorded in official histories, but built into the stones and earth beneath cabin floors across the Rocky Mountain frontier.